In this particular problem, we're going to look again about how we can use a second derivative test and see when it can't be applied if we're given a function in this first derivative. So in this question, you're asked, hey, which of these problems can I not use a second derivative test at the critical point x equal to 2? And you'll notice that every single one of these functions that are given, the first derivative is also given, and x equal to 2 is a critical point since the original function is continuous at x equal to 2. It's defined there. And also the derivative is actually equal to 0 at every single one of these at x equal to 2. F prime of 2 is 0 here, as well as here and there and there. So what we need to do is figure out, is the second derivative at 2 equal to 0, which would mean that the second derivative test is inconclusive. Now we're going to do a process of elimination here. We're going to look at the easy functions that we take derivatives of, and we're really not going to worry about this 1b. It may be the answer. It turns out it's not. Mainly because a second derivative would require me to use the product rule, or to be a little bit more creative and say, oh well, the derivative x e to the minus x is going to get reapplied here. But I really want to avoid using too much. I want to be able to get to this problem, get the answer quickly. So the second derivative of this function is going to be cosine of x minus 2 with a minus in front. We evaluate that at 2, we get a negative. So move on. What we're looking for, it's a second derivative equal to 0. This one, the second derivative is equal to 2. It's not 0. Second derivative test can be applied. And this one, we take the derivative, second derivative, I end up with a 6x minus 12. You evaluate that at 2. Second derivative is equal to 0. Therefore, the second derivative test is inconclusive. And we choose B without ever having even to look at part B.